When a standard six-sided die is rolled n times, the product of the n numbers rolled can be any of the 936 possible values. What is n? So for this problem, we're going to start with a slightly clever idea that we're going to look at the number of rolls that are fives and rolls that are not fives. The motivation behind this is that the faces of the die are numbered 1 through 6, and other than the number 5, the remaining numbers are divisible by 2 and or 3, or neither. So let's assume that there were C rolls that are not fives, and n minus C fives. So what we're going to do is we're going to find, in terms of C, how many products are possible that do not use the number 5. Once we do this, this expression will also equal the product of the number of products that we can obtain, because the number of fives will be uniquely determined at that point. So we're going to answer the question in terms of C, how many products how many products can we obtain where the dice rolls are 1, 2, 3, 4, or 6? So in order to answer this question, let's start by looking at the extreme cases, or in other words, the largest possible products we can obtain. So we see that if I were to roll all fours, so in other words, if I were to roll C4s, then the product would be 2 to the 2C, because 4 to the C is equal to 2 to the C. On the other extreme end, if I rolled all sixes, then the product would be 2 to the C times 3 to the C. Now let's look at another case where maybe I don't roll all fours or sixes, but I roll some combination of fours and sixes. If I rolled all fours except for 1 6, then the product would be 2 to the 2C minus 1 times 3. Similarly, if I rolled all fours except for 2 threes, or 2 sixes, then my product would be 2 to the 2C minus 2 times 3 squared. So we see that each of these products can be obtained by rolling only fours or sixes. Next, we observe that if 4 is replaced with a 2, or 6 is replaced with a 3, then I can obtain any product that is any of the above products divided by a power of 2. So in other words, I can obtain the numbers 2 to the 2C minus 1, 2 to the 2C minus 2, all the way up to 2 to the 0. And of course, 2 to the 0 occurs only when I roll ones. Similarly, I can obtain 2 to the 2C minus 2 times 3, all the way up to 3, or 2 to the 0 times 3, and so on and so forth. So with 2 to the C times 3 to the C, I can obtain the numbers 2 to the C minus 1 times 3 to the C, all the way up to 3 to the C. So it's worth remarking that this table that we just constructed lists all possible products. Because we can also note that if a 6 is replaced with a 2, then I can obtain the product obtained by dividing the previous product by 3. However, this will already be counted. So I just need to count the number of products in this little table that we just drew. So we see that the leftmost column has 2c plus 1 products. So let's write 2c plus 1. The second column from the left has 2c products. The third column from the left, so this will be 2 to the 0 times 3 squared. The third column from the left will have 2c minus 1 products, and so on and so forth, until the rightmost column has c plus 1 products. So this expression is the number of products with c rows that are not 5s. And this is an arithmetic series, so we can compute the sum by looking at the number of terms, which is c plus 1, and then multiplying by the average of the first and last terms. So we have c plus 1, and then the average of the first and last terms is 3c plus 2 over 2. So 3c plus 2 over 2. This gives the number of products in terms of c. And so the sum from c equals 0 to n of this expression gives us the total number of products. So we want to find n such that this sum is equal to 936. So if I multiply both sides by 2 to get rid of the fractions, right, we need to find n such that the sum from c equals 0 to n of c plus 1 times 3c plus 2 equals 1872. Now let's look at the answer choices. We can actually just guess and check at this point, starting with the middle answer choice, which is E. So if n equals 9, we see that the sum from 0 to 9 of c plus 1 times 3c plus 2. I'm going to skip the computation, but you can check that this is equal to 1100, which is less than 1872. So therefore, n has to be greater than 9. You see that if n is equal to 10, then the sum from c equals 0 to 10, this is equal to 1100 plus the expression where c is equal to 10, 11 times 32, and this is equal to 1452. Again, this is less than 1872, which is what we want. Finally, if n is 11, then the same sum, but from c equals 0 to 11. This is equal to 1452 plus this expression where c equals 11, 12 times 35. 12 times 35 is 420. So we get 1872, which is what we want. Therefore, n must be 11, and the answer is A.